Hi everyone. Uh, this is not one of our usual videos. For this video, I'm going to talk a bit about Lab 4, and specifically the Caesar Cipher. And I'm making this video because I've seen a lot of questions about this problem. There's a couple of intricacies here, and uh, because this is a bit of a trickier problem than you're used to, I wanted to help give some hints for those of you who are still kind of stuck. So let's take a look at how to approach this problem. So first, reading the instructions is important. There's a lot here. There's this, we talk about what a Caesar cipher is. A Caesar cipher is where you shift characters in a word. So what does that mean? That doesn't mean shift like, ABC becomes CAB. This means shift characters like, let's see, ABC with a kind of shift index count of, let's say, 2, becomes, let's say input ABC, output becomes, A gets shifted 2, so ABC, so C, D, E. So shift of 2 here means each letter moves forward by 2. But now an important point to make is that for this problem, one, punctuation doesn't get encoded. Or really, if we want to be really precise here, only letters get shifted. In our problem here, only letters get shifted. Let's see. And number 2 here, whoops. We want our letters to shift around. So any letter shifted beyond Z wraps around to A. So what does this mean? This wraparound property. So this means that, let's say we have an input like input XYZ, and we're going to have our shift value be 2 again. Okay, well, let's shift X by 2. So X, Y, Z. So X becomes Z. Let's shift Y by 2. So Y, Z, we're out of letters. We're actually going to shift all the way back around to A. So you can think about it as we have our here we go. So Y becomes A. Now Z shift by 2. So Z shifts to A and then to B. So we get ZAB. And so the way you think about this is A, B, C, D, E, F, G, H, H, K, L, M, P, Q, R, S, T, U, W, X, Y, Z. What you're going to do here is, as you move forward, X, Y, Z, Z then goes on to A, B, C, D. And the same thing happens on the other side. So if you have to shift backwards, which you have to do to decode, we're going to put Z before, and then Y before that, and then X before that, and then W before that. And so encoding any letter with a shift of, X or whatever it is, a shift of 2 means you start from that letter, and you're going to move however many to the right. So X, shifted by A shifted by 2 here moves 2 to the right. So A becomes B, C. And then decoding, you know that the shift was 2, so to undo that, you shift 2 to the left. So an encoded string shifted by 2 with the letter C becomes A, because we move 2 to the left. Now, let's look at this code here. So reading through here, we have some examples. Our code is going to ask, do I encode or decode? Let's see. So let's go ahead and paste this starter code in. Now, by the way, notice I'm working in Replit here. So I highly encourage you all to be working in Replit, not in the Mimir kind of code writer, because you can't run your code there. You can only run the tests. And sometimes the output, the error messages are kind of confusing. So highly encourage you to just write in the Replit here. So our input, what would you like to encode or decode? Let's look at what our code is doing first to make sure we understand. So encryption option, this will take in, would you like to encode or decode? This will return us a string that gets stored in encryption option. Okay. And then we have these two Booleans. So encode in encryption option.lower. You haven't seen this in keyword yet. All this in keyword does is it checks if something is inside of something else. So if the substring encode is found anywhere in the encryption option in lowercase. And same thing here, should decode. Is decode in encryption option.lower? This is going to tell us what branch of our code to execute, because down here we have if should encode, do something, if should decode, do something, otherwise do something else. Another thing you might notice here is this pass statement. So that's kind of weird. What is this pass keyword? I've mentioned it in class, but you haven't seen it much. Pass means do nothing. It's just empty placeholder text. And it will kind of sit here, and the reason we have it is because we have no code written here. And so usually in skeleton code, you'll see it like this in starter code, and you're going to replace it with your own code. It's only there because Python wants some sort of code in this indent. Like if I get rid of this, it will be unhappy because Python expects at least one line of code in a block. So we need something, and that's why we put pass. But as you write your code, in each section, you're going to replace it. So why don't we start with some kind of just toy code? I am encoding. So that'll get printed if we're encoding. Maybe in here we can put I am decoding. And finally at the end, it says print a nice notice that we only support encrypt and decrypt. Okay, so let's let users know. So if we go, should encode is true if the user gave us encode as the command. Should decode is true if the user gave us decode as a command. And this is the case where neither should encode nor should decode is true, which means that here we're just going to tell the user, we only support encoding and decoding. Sorry. So maybe let's just run our code and sanity check that what we think is happening is actually happening. 3 main.py. So run this. Would you like to encode or decode? Okay. Encode. Great. It says I am encoding. That's good. That's what we wanted. Let's try that again. Would you like to encode or decode? Let's say decode. Cool. It now says I am decoding. And finally, if we run this, let's say we enter something else. I want you to add, please. We only support encoding and decoding. Sorry. So now we know what each of the commands is that triggers our branches. Now, the instructions also say, let's ask the user for their message and cipher number. And so we know how to do that. Let's take our input message here. So message equals input, enter a message, cipher number equals input, enter your cipher number. And we know the cipher number is going to be an integer from the instructions in the program. We know that it'll be 1 or 2 or 10 or 15. It's however much we're going to shift all of our letters by. And why don't we just print them out here? So I'm encoding message with cipher number. Whoops. So if I run this code, again, sanity check that everything's working the way we intend it to. Let's say encode. My name is Alex. That's going to be my message. And my cipher number, let's say, is 5. So I am encoding. My name is Alex with cipher 5. This looks pretty good. Now we get into the meat of the problem. How do we write code that will encode our message? Let's go back and see what happens. So it gives us some context here about an ORD function and a char function. So we've talked about data types in Python. We talked about strings. We talked about numbers. Remember how I said that everything under the hood is ones and zeros? It's bits in memory. Well, these characters are no exception, actually. Even though we type them in quotation marks, each character actually has a number under the hood because number transits to binary. So all this number means, and let me just show you first. I'll say a little more in a second here. These are called ASCII numbers. ASCII stands for American Standard Code for Information Interchange. And you can click one of these links to see a table that you can use. It has an ASCII table online. If we scroll down a little bit, there's a whole bunch of these weird characters at first. There's punctuation and stuff here. A Sephora ad. I've got integers. And finally, our letters start from 65. So uppercase A is 65, going up by 1. Uppercase B is 66, so on and so forth, up through 90. And then lowercase a is 97. And this just means that in memory, what Python actually stores is 11000001, and it labels that as the type character. And so Python, the computer knows to interpret that memory as a character. And so instead of the number 97, it interprets it as the letter A, but they're represented the same way. And Python provides you a function that you can use to get the ASCII value of any character you want with the ORD function. And so, why don't we do that here? So instead of printing out this I am encoding, let's look at each character. And by the way, this is a perfect place to use a for loop for each character in our string, in our message. Going to print out the number for our character. So the number, the ASCII index, we use this ORD function. We give it one character. So let's print car, and then we'll print a colon, and then we'll print ORD of car. So this line of code here is going to go through our message and print out one character at a time, the character and the index, ASCII index. So I'm going to encode. Let's enter a message. I'm just going to do Alex for now. And let's say, I don't know, 2. We're not using the cipher number yet. So, all right. So we see that A has a number of 65, L has a number of 108, E has a number of 101, X has a number of 120. So let's try something a little different. Let me run this again. And let me try ABCD. Oops. All right, well, I broke that. I'm going to enter encode first, ABCD. I did it wrong again. So I want to encode for now, ABCD. Say cipher number of 4. Notice how the indices go up by 1. So A is 65, B is 66, C is 67, D is 68. Can you think of a way to use this for a cipher? I'm going to give it away here. If you want to get, 2 letters forward from A, you're going to add 2 to the ASCII index to move from 65 to 67. And we know now how to get from a character to its ASCII index. We'll use the ORD function. So ORD of A gives us 65, ORD of B gives us 66, and so on and so forth. We don't know yet how to translate back. And so let's find a way to do that. So let me go ahead and actually, I'm going to make a new file here that'll let me focus on just this part that we're talking about, just for demonstration purposes. So, car message. Whoops. So let's say, again, we're going to take our message. That's all we need right now. So car.py. Our message, let's say our message is Howard. So yep, so we print all these out. Now, what if we wanted to get back ASCII index equals ORD car. So this ASCII index, we want to use this ASCII index to move on to the next character. So let's try that. You can go to the next character by adding 1. So how do we do that? We're going to do next car index equals ASCII index plus 1. And now to translate from a character index, ASCII index, back to a character, we use the CHR function. And see, you can see here the description of this function. It returns a Unicode string of one character with ordinal, which is another word for this ASCII index, I. So we give it input of this next car index. And this will give us the next character. So if I want to now use this, I can print out next character, next car index. If I run this here, Howard, you can see H became I, right? A, B, C, D, E, F, G. H became I. O became P. W became X. A became B, so on and so forth, because that's the next letter. So this works. This works. And it doesn't have to look so ugly here. Like, we could actually make this all in one line, right? So the next character, let's just combine some of these lines. So we don't, ASCII index doesn't need its own variable. We can say that the next character index is the current index plus 1. Now, another thing I want to fix here is we're printing everything on one line, but what if we want to make a single string with this? So output stir because empty string. We can start with an empty string. And remember, we know how to concatenate strings. So what you can do is for every character, once you get a new kind of character you want to add on to your output, you can do output stir equals output stir plus next car, plus CHR of next car index, which is going to convert that next car index into a actual letter. And at the very end, we can print output stir. So A, B, C, D. You can see it becomes B, C, D, E because everything gets shifted by 1. A becomes B, B becomes C, C becomes D, and D becomes E. This is great. But you're going to ask me, hey, what if we run this again and I enter X, Y, Z? What do you think will happen? So X becomes Y, Y becomes Z. What do you think Z is going to become? Let me run it. So Z actually becomes an open bracket like this. And so if I go back here and take a look at why that is, so a capital Z is index 90. And when we add 1, index 91 is the left square bracket. So we need some way of converting back from the open bracket back around to the capital letter A. Now, how do we do that? Well, there's a couple of different ways you can do this. But the simplest way is to just subtract 26. So we know that there are 26 characters. So if I go here, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so these are all the characters. There's 26 of them. So 0, 1, 2, 3, 4, 5, et cetera, et cetera, et cetera, all the way up to 26. So just take a look. Oops, 25, because we're starting from 0 in Python. So just take a look at this. If you wanted to get from index 26 here, which would be whatever character comes next here, which is kind of an open bracket, right? We want to actually shift back all the way around to A. Instead of Z should be Z, 25 should be Z, but 26 should go all the way back around to A. So the way that we do that is we subtract 26 because that'll get us shifted all the way back to the beginning. You can almost think of it as these next characters that come. So if we look at this table, open bracket slash close bracket slash close bracket, et cetera, et cetera, et cetera. If you were to paste them down here, this is how you get them to wrap back around to the beginning. So you give them the same index as the start by subtracting 26. So let's try that. How do we know what to do? Well, if our next car index is greater than 90, let's see, well, what do we need to be greater than? If we are at 90 or greater than 90, so 91, greater than 90, we're going to want to subtract next car index equals next car index minus 26. And that'll get us to shift back to the beginning of the alphabet. So 91 will become, let's see, 91 minus 26 gives us 65. If we take a look here, index 65 is capital A. So that does exactly what we want. And so if we run this again, and I enter X, Y, Z, this now shifts back around Y, Z, A. And that's really great. And why don't we try some other shift amount? So, I don't know. Cipher index equals int input a cipher index. Cipher index. So I run this and I enter, I don't know, XYZ, and I want to shift it by 3. What would you expect this to become? So X shifts to Y, Z, A. So Y and Z probably are B and C, so we probably should get A, B, C. And that's in fact what we do get. Now, one more wrinkle here that you need to think about is uppercase and lowercase letters are separate. So there's uppercase letters and lowercase. And so actually uppercase letters are bigger than 97. And if I were to run this exact code, sorry, bigger than 90, lowercase letters start from 97. So if I were to run this code again and enter a lowercase string, our code's not going to handle it. Shift by 3 makes it JKL for some reason, right? That's kind of weird. ABC shifted by 3 should be DEF, but it's not. And we have to think about why here. Well, what is the ASCII code for A? The ASCII code for A is 97. So ASCII code for A, 97. Let's look at what our code does. We add the cipher index, so 3 to 97. And looking at our table, that should work. We should get 100, which is D. But the problem is we have this condition here that checks if our index is greater than 90, we subtract 26. And that's not, that's not good. So because in this case, this just fixes our code for the case of for the capital letters. So actually what we need is we need separate behaviors for our capital and our lowercase letters. And this is where comments will help. If given letter is capital, so how do we know if a given letter is capital? Well, if the word car is in some range, right? So all of our capital letters have an index less than or equal to 90 and greater than or equal to 65. So that's exactly what we can check in our code here. So if our code is greater than or equal to 65, or our code is less than or equal to 90, then we're looking at a capital letter. In that case, we're going to do, this special shifting. Whoops. Special shifting where if we shift too far, our next car index here, if it gets shifted too far, we need to kind of shift it back. And then we want a different case if given letter is lowercase. And how do we know if the letter is lowercase? Well, we look at our code here. It starts from 97 and goes up to 122. So if ord car is greater than or equal to 97, or ord car is less than or equal to 122, then we're going to need to do something similar. So what's the Z? Z is 122. So if ord car is greater than or equal to, specifically what I want to check is if our new character got pushed beyond 122. So if our next character index is greater than 122, we're going to make next car index equal to next car index minus 26. And that's what we do here. Now notice, by the way, we have something kind of interesting here. So let's run this and see what happens. This should give us some kind of help. So Alex, all caps, let's see, shifted by 1, BMFY. Yeah, that's right. So A becomes B, L becomes M, E becomes F, Y becomes X. That's okay. Well, let's run this again with, so I'll do it with capital letters shifted by 2. Yeah, CDE, that's right. Let's try it with lowercase letters. So ABC. Let's see what we did here, actually. So ABC we thought would become DEF. Let's see if we can fix this. What is wrong with our code? So IJK. Ah, can you spot the error in my logic? Maybe you're following along. Take a look. I used OR here. So we're not checking that it is within the range 65, greater than 65 and less than 90. We're just saying either greater than 65 or less than 90, which, by the way, all numbers are either greater than 65 or less than 90, right? So this isn't useful at all. Every single number matches this condition and enters the inside of this conditional here. And so that's causing my bug, and so I need to change OR to AND here, because we're checking that it's inside of the alphabet there. So if I run this code and I do ABC, shifted by 3, we now see DEF, which is great. And if I run this again and I give it lowercase xyz, shifted by 3, and we run this, we see ABC. So it shifts all the way around the way it's supposed to. Wonderful. Now, one thing our code doesn't handle is spaces. So what about ABC space XYZ? And a cipher index of 3. Well, this space kind of got used here. And we don't want to shift spaces, right? So you might have to restructure your code a little bit, this code here. I'm not going to give away how, for the case where this condition doesn't match and this condition doesn't match. So if the letter isn't capital and the letter isn't lowercase, we don't want to add this cipher index. So think about what you can do here. It's really helpful, actually. Yeah, think what you can do here, how you can restructure your code so that you don't always add this next character index, add the cipher index to the next character index. We want to leave space, anything that's not a character, we want to leave it alone. Now this tells you a bit about how to encode characters. You still need to think about how to decode them, and I'll leave that up to you. Please take post on Piazza if you have questions. Otherwise, come to office hours tomorrow and we'll try to help you out there. Hope this helped. Bye.